Hi students, welcome to Mathonic. Today I'm going to discuss the chemistry paper 4 theory extended February March paper 0620/42. Okay, so let's start. The first question is given that using the numbers only state the percentage of oxygen in the clean dry air. Okay, so the answer is 21 percentage. Okay, listen, so in air we have nitrogen is 78 percentage, oxygen is 21 percentage, and noble gas and carbon dioxide including is 1 percentage. Okay, next question is given typical operating temperature in degrees Celsius used in Haver process. See, the answer is 450 degrees Celsius. I try to give extra information in every question because you can have that knowledge. If the question comes in different way, you can answer this properly. Okay, see, what is Haver process is? Haver process is known as the manufacturing of ammonia. Okay, for that, as I told you, we need a temperature of 450 degrees Celsius. Pressure we need 200 atm. Catalyst for this we need iron. Okay, it is an exothermic reaction and the process is N2 plus 3H2 that becomes 2NH3. Okay, yes. Number of atoms in a diatomic molecule, the answer should be 2 because we know that diatomic molecule means 2 atoms in one molecule. Okay. The maximum number of electrons in the second electron shell should be 8 because we know that in first shell we have 2 electrons, in second shell we have 8 electrons. Okay. Number of hydrogen atoms in an alkane with 7 carbon atoms is 16. How? Listen, the general formula of the alkane is CnH2n plus 2. CnH2n plus 2. You can see here, as per the question, if carbon is equals to 7, so we can say CH2n plus 2. That means that is H of 2 times 7 plus 2. That becomes what? 16. So for carbon 7, you are getting hydrogen 16. Then number of particles in 1 mole in standard form, that is known as Avogadro constant, that is 6.02 times 10 power 23. Got it? Next, question number 2. Question number 2 is given that this question is about ionic compounds. State what is meant by term ionic bond. See, the ionic bond is defined as the strong electrostatic attraction between oppositely charged ions that is formed between the metal and non-metal. Got it? When we have opposite charge ions in between them, the force of attraction will be known as electrostatic attraction and that will be known as ionic bond. Okay. Next question is potassium sulfide, which is given K2S, is an ionic compound. Complete the dot in cross diagram from this of this figure, that is potassium sulfide. Okay, so you can see here, this is K is potassium, and S for sulfur. You can see here, as per the periodic table, for potassium this will be the known as what? Proton number. So 19 is the proton number. For sulfur, 16 is the proton number. Okay, so we know that number of protons is equals to number of electrons. So if we have 19 electrons, so for that also we have 19 protons as well, right? So 19 electrons, if I try to configure in electronic configuration, we know that first shell it contain 2 electrons, second shell it contain 8 electrons, third shell will contain 8 electrons, and final I'm getting 1, 2, 8, 8, 1. Like that, the electronic configuration for 16 electrons will be 2, 8 and 6 for sulfur. See, here this excess 1 electron is to be donated, is to be given by the potassium, right, to be more stable. And like that, here outermost electron is given 6, so it will try to receive 2 electrons more to become more stable, to become a complete cell. Got it? So that's why you can see here, so this is 2, this is 2, this is 2 and this is 2, right? This is 8 electrons, you can see here. And in sulfur, outer we have how many electrons? We have, see, this is 1, 2, 3, 4, 5, 6 and 2 electrons in needs. Okay, that's why I've given the dot here. This is exactly same with this potassium as well. Do you understand everyone clearly? Okay, next part is this figure is like ionic compounds form a giant ionic lattices. Okay, this figure shows a part of giant Ionic lattice structure of sodium chloride, NaCl. Okay, complete this diagram to figure to show that ion present. We use plus for sodium ions and minus for chloride ions, and one chloride ion has been completed for you. You can see here this is given minus. Okay, you should remember negative will be attracted to the positive, so draw opposite charges connected to each other. That means this negative is connected to these two atoms, right? You can see here this also plus, this will be plus. If this one is plus, this is connected to minus, this is connected to minus as well. If this is minus, this will be plus. If this is plus, this will be minus. This is plus, this will be what? Sorry, this is minus, this will be plus, and this is also plus. So this is how we have to, what I can say, draw this one. Next question is given, state the name of given to any positive ion. So that name should be cations. See, basically we have two names, one is cations and one is anions. Okay, what is cations? Any atom donate electron to form a positive ion, that is known as cations. Okay, any atom receives electron to form negative ion, that is known as anions. Got it? See, I have given like extra information for this one, right? So you can have a knowledge for each question. So yes, so you can read that extra note, so that if the question changes in a new paper, so that you can reply the answer in proper way. Ionic compounds can be decomposed by the passage of electric current using inert electrodes. Okay, state the name of this process. Yes, this process name is named as electrolysis, because electrolysis is a process in which a molten ionic compound is broken down by electric current. That's why it is known as electrolysis. Write the ionic half equation for the reaction which takes place at the node when molten potassium bromide KBr is decomposed by the passage of electric current. Okay, before going to this equation, let me explain some basic things for this one. Listen, ions present inside the molten potassium bromide will be what? It will be K plus and Br minus. Okay, see, this molten means what? It molten means there is no water molecule present. That means there is H plus and OH minus will not be presented. Do you understand what I'm trying to say? Now what happens? This positive ion will be attracted to the negative terminal, that is cathode. Got it? And that negatively charged ion will be attracted to the positive terminal, which is anode. Did you get it? Right. So if I try to show you this figure, like this is the battery we have, this will be cathode, this will be anode, like this. Okay, so you can see here that electron flows out of negative terminal and goes into the positive terminal, right? So at anode you can see here the electrons leaves, electrons are donated, right? So what happens? So bromide Br minus, which is bromide, will donate electron to become bromine. You can see here that bromide will donate electron to become bromine. You can see here. Next we can balance each other, because we know bromine is Br2. Here 2 bromines, so I have multiplied 2, and 2 negative ions, so I have multiplied 2 here. This is how we can balance it. Do you understand clearly? Right? Name the products and state the observation at the negative and positive electrodes when dilute aqueous potassium bromide KBr is decomposed by the passage of an electric current. So the product at the negative electrode. So product of the negative electrode will be hydrogen gas. Okay, product of negative will be hydrogen gas. Okay, before going to this question, let me explain one more thing. So listen, aqueous solution means what? It means ions present right now. What are they? It will be K plus, it will be Br minus, it will be, because aqueous means we have right now water molecules present, H plus and OH minus, all these ions will be present right now. Okay, so what happens? So negative terminal will attract H plus and K plus ions, because that opposite charges attract each other, right? And positive terminal will attract what? Like Br minus, bromide, and hydroxide ion, that is OH ions. Did you understand clearly? So since it is a diluted solution, we'll choose ions to be discharged based on electrochemical series. Did you get it? right? So yes, this is will be based on electrochemical series. Okay, for positively charged ion, you can see here we have two positively charged ions. One is H plus and K plus, right? H plus is placed at the lowest of electrochemical series. For positively charged ion, H plus is placed at the lowest electrochemical series, and for negatively charged ion, OH minus is placed at the lowest electrochemical series, that is hydroxide. So what I'm trying to say is, out of this, see, we have, I told you right now that K plus, this is Br minus, right? And here we have H plus, and this will be like OH minus, right? So by the, like, if I talk about electrochemical series, thus H plus will be the lowest between these two. If I talk about ACS, between these two, the OH will be the lowest one. So what happens is, so half equation for negative electrode will be like this one. See, this will be like this: H plus plus E minus, this will be H2. Okay, if I try to balance it, it will be 2H plus plus 2E minus, that will be H2. You can see here, right? So because negative electrode will receive electrons, and for OH minus, you can see here, right? For OH minus, or we can say for hydroxide, we have to memorize the half equation. That equation should be 4OH minus. That will give you 2 molecule of water plus oxygen and plus 4 electrons. Okay, so get back to the question. Product of the negative electrode, what they will give you? They'll give you the hydrogen. You can see here observations at negative electrode, that means it will be colorless bubbles. Products at the positive electrode, that is water. You can see here positive, this is the positive electrode, so it will be water. And observations at positive electrode, that will be colorless bubbles, because these are exactly same. Got it everyone clearly? Okay, next part. The halogens are a group of elements in periodic table. Right? The chlorine is a member of this group. State the group of members of the halogens. If I try to show you the periodic table, you can see here, this is, you can see here, right? This is periodic, this is group 1. Group 1 is known as alkaline metals, right? You can see here that group 7, this is known as halogens. Group 8 is known as noble gases, and group 3 to from here you can see here the group 3 to group 12 are known as transition elements. Got it? So yes, so you can see here the group 7, this group 7 are known as halogens. That's what the question is all about. Got it? Now next question is that how many halogens are there in this group? 6 elements. You can just count it. How many elements? 1 2 3 4 5 6. So in group 7 we have total 6 elements. Suggest the identity of halogen okay, has the highest density. Okay, in listen, as the element goes down the group, it gets heavier. What does it mean? The density increased. So at the bottom of that group 7, you can see TS, or we can say tennessine, will be the highest density element, right? Which is most reactive, we can say. As the element moves up the group, it is more reactive. That means the element which is present at the top of the group, that will be known as fluorine, or we can say that is more reactive. Got it? So if I try to show you here, you can see here, you can see here, yes, this is the halogen group. You can see here group 7. At bottom we have TS, as I told you that this will be have the heavier mass, heavier density, and fluorine at the top, this will have the like high reactive. Got it? Yes. Next question is, yes, state the name of the negative ions formed by the halogens. The name is halides. So you have to remember this one. Okay, state how many occupied electron shells are there. Bromine atom, it will be 4, because bromine atom is placed in period 4, which means it has 4 shells that occupy electrons. If I try to show you the periodic table again, you can see here period means, you can see here this line will be known as period 1, this will period 2, this is period 3, and this is period 4. If I go for period 4, you can see here bromine is placed in period 4. That's why it has a 4 shells. Okay, right. Now aqueous chlorine Cl2 reacts with aqueous potassium, that is Ki, potassium iodide. One of the product is formed as iodine, that is I2. So complete and balanced ionic equation for the reaction between chlorine and the iodide ions. State symbols are not required. So it's easy. So how we can do this? Listen, if I try to tell you that how to find this, I told you that, see, remember in group 7, if I talk about group 7, if I write down the elements, this is fluorine, this is chlorine, this is bromine, and this is iodine, like this, right? So if I go down the group, right, it becomes less reactive. I told you already, if I go down, it will be less reactive. If I go up, it will be more reactive. Do you understand clearly? So you can see here, the chlorine is placed above the iodine. That means chlorine is more reactive than iodine with compared to iodine. Do you understand? So when chlorine will react with compound that consists of iodine, it can displace iodine to become like KCl. If I talk about KCl, right? For example, see, if I say this is Cl2 is given plus I'm talking about Ki, right, is reacting this one. So this is more reactive than iodine, right? So it will replace this. If we replace this, it is getting KCl plus iodine. You can see here, right? So yes, so for this case also, this chlorine will produce, right, that iodine, and it will create chloride, right? And you can see your balance. You can do this because here we have Cl2, so I'll put it here 2 chlorine, and this is iodine 2, so we can put here 2 iodine, right? 2 iodide ions. Okay, explain why this reaction is defined as a redox reactions. Give answer in the form of electron transfer. Oxidation and reduction takes place at the same time. Chlorine gains electron and is reduced, okay, and iodide ions lose electrons and are oxidized. This is the definition you can write down, which is easy for you. I think I missed this question. Name the noble gas which has the same electronic configuration as bromide ion. See, very simple. All of us know that bromine has 35 protons, and we know number of protons equal to number of electrons. So that means if I try to find out how many electrons do you have for bromine, it will be 35 electrons, right? However, to become more stable, it is in the group of 7. That's why it will receive one more electron, okay, to become 36 electrons, okay, and it will become bromide Br minus. So it will receive one more electron and become bromide ion, and bromide ion have 36 electrons. It like that. So krypton, that is Kr, also have 36 electron. That is the answer, should be krypton. Okay, next question is given that, yes, give the color and state of iodine at room temperature and pressure. So see, I have written here, you can see here the extra information I gave you. The group 7 elements, their physical state and color I have given. So fluorine, the physical state room temperature will be gas, and this color should be yellow. Chlorine, it will be gas, and it should be green. Bromine, it should be liquid, and this should be red brown color. For iodine, for this question is asking for iodine, right? At room temperature, the physical state would be solid, and color should be gray black. What is that? Gray black, and it forms purple vapor when heated. When you heat it, this the vapor will be like purple color. Okay, now question number 4. Carbonyl chloride COCl2 is manufactured by reacting carbon monoxide with chlorine. So carbon monoxide, this is chlorine, this is COCl2. Okay, and this is enthalpy change is given -105 per, like what I can say, per mole, kilojoule per mole. Okay, you can see here this enthalpy change is negative, means negative symbol indicates it is a what kind of reactions? Exothermic reaction. That you have to remember, everyone, right? And this symbol means it is a reversible reaction. Always remember, this forward reaction is a see, listen, for this case, this value always give you about forward reaction, right? And negative value, what is given? Exothermic reaction. Do you understand clearly? Now the process takes place in a closed system and equilibrium is reached. The condition for this process are 200 degrees Celsius and 200 kPa, the pressure we're talking about. Explain what is meant by term closed system. See, a system in which no reactants or products can enter or leave, that is known as closed system. Okay, State what the symbol del H represents. I told you that, and this is known as enthalpy change. What is enthalpy change? Enthalpy change is the heat that passes into or out of the system during a reaction. State how the value of delta H or enthalpy change shows that forward reaction is exothermic. So basically simple, I told you already, if this is negative, so delta is negative, that's why we can say this is exothermic. Now deduce the value of delta H for the reverse reaction, include a sign in your figure. You can see here, I told you already, this value always give you about forward reaction, got it? And if this is negative, so here the forward reaction will be exothermic, right? That means reverse reaction should be endothermic, very simple. So then opposite reaction should be endothermic, and if forward reaction is positive, so backward reaction will be like negative. If forward reaction is negative, backward reaction will be positive, and yes, magnitude will be exactly same, which is plus 105 kilojoule per mole. Okay, next question is given. Complete table 4.1 shows the effect that, if any, on the concentration of COCl2 at equilibrium when the following changes to the conditions are applied. Okay, we'll try to understand this. You can see here from this question that COCl2 is the product of the reaction, correct? So use only three words, that is increases, decreases, so no change in this. Okay, if you see this question, changes to conditions. When temperature increased, what will have the effect on concentration of CaCl2 at equilibrium? That is the question was all about. See here, I have already written the notes, you can see here, right? Remember, when you increase the temperature, it will favor the endothermic reaction. And for this question, endothermic reaction is a backward reaction. For this question I'm talking about, right? So yes, the position of the equilibrium shifts in the favor of endothermic reaction. That means for this question, since it's a reversible reaction, so this will be shift to the left, right? So I've written here, position of equilibrium will be shift to left, and this will this will decrease the concentration. Did you get it? Next question is, some carbon monoxide CO is added. What happened? Increasing concentration of reactants favors the formation of more products. That means the position of equilibrium shifts to right to reduce the concentration of reactants. Obviously, when you add some like product, right, so it will shift right and it will increase the concentration. Did you get it what I'm trying to say? Yes. Now the pressure is increased. If the pressure is increased, what happened? I've written here, increase in pressure favors the side of with the fewer moles of gas, right? You can see here that this is 1 mole of carbon dioxide, this is 1 mole of chlorine, right? That means including 2 mole of reactants are giving you 1 mole of this one. Yes or no? That means here right hand side, the product side is lesser one. So we can see here that position of equilibrium shift to the side with fewer moles. So fewer moles at right side, so shifts right, so it will be increasing concentration. So when catalyst added, remember there is no effect, so there will be no change. The catalyst only, what happens, it will only increases the rate of reaction, or we can say speed of reaction, when catalyst is added. Did you get it everyone clearly? Right, next part is given. The equation for the reaction can be represented as shown in here. You can see here enthalpy change is given negative 105 kilojoule per mole. So question is given, it shows some bond energies. So a triple bond energy is given, chlorine energy is single bonds, and carbon chlorine is given 340, right? Question is given, use the bond energy in table. The value of delta H for the reaction to calculate the bond energy, the kilojoule, and carbon double bond, right? Use the following steps, calculate the energy needed to break the bonds in the reactants. In the what? Reactants, correct? If you see here, this contains like triple bond, which is 1075, and this chlorine we have a single bond which is given 240. So this is the reactant parts. We can see this because we need to find out the reactant energies, right? Please try to add these two values. We can say 1315 kilojoule. Now calculate the energy released when bonds in carbonyl chloride form. Very simple. The formula, if I try to write down, I've written here the formula. You can see here, this is known as the reactant side, this is known as the product side. You can see here, right? I have written here bond broken minus bond formed, that is known as enthalpy change, which is equals to delta H. So I need to find out the energy energy for the bond form, rearrange it. So bond broken, that is minus delta H, or that is enthalpy. So 1315 minus 105, this answer should be 1420. That's what I have written here. Calculate the bond energy of C double O bond. Okay, you can see here we got this like formation of this bond energy, we got 1420, right? You can see here how many here, 2 CCl bond, you can see here, and 1 C double O bond, right? You can see here 2 CCl bond, carbon chlorine bond, and 1 carbon oxygen bond, that equals to energy of 1420. So a carbon and a single bond we got 340, so I am replacing here this will be 340, right? And this is carbon oxygen double bond, that equals to 1420. So if I try to rearrange it, so this gives you, I think, 680. If I try to shift to other side, 1420 minus 680, we got 740 kilojoule per mole. Do you understand everyone clearly? Yes. G. Complete the dot in cross diagram or in figure 4.2 molecule carbonyl chloride and shows outer shell electrons only. Okay, so here we have chlorine. Carbonyl chloride means chlorine, carbon, oxygen. So if I try to write the what I can say electronic configuration, it will be 2 8 7 2 4, because carbon has 6 electrons, chlorine has, we have 17 electrons, and oxygen we have 8 electrons. So that's why it's 2 6, and this 7 4 and 6 are the outer electrons, outer shell electrons, right? Now listen, this is 7 means what? Need 1 electron to be more stable. This is 4 means needs 4 electron to be more stable. This is outer 6 because it needs 2 electron to become more stable, right? See, so carbon needs how many electrons? 4 electrons. So carbon also, I put a cross and cross. This is on, right? It needs 4 electrons more. 1 2 3 4. Can you see this? Like that. Oxygen, we have outer how much? 6. So this is 2 4 6. So it needs 2 electron. Did you get it? Like that. For this one, chlorine we have 7. So 2 2 2 6, this is 1 7, and this one is shared. Do you understand? So like that, 2 2 2 6, this is 1 7, and this one is shared. Did you get it? So make sure that everybody has like outer shell electron should be 8 electrons. Okay, so next part. So okay, so if you understand very well, please try to subscribe and do share this video with your friends. And yes, because upcoming IGCSE exams are coming, so I'll be uploading physics, chemistry, and maths papers, and also biology papers will be uploaded as soon as possible, right? And please do comment what videos you need to be like displayed in the YouTube, or what videos you need to be taught online. So please do comment on that also. Question number 5. Manganese is the element with atomic number 25 in periodic table. Calcium is the element with atomic number 20 in the periodic table. Okay. Complete the table to show the number of protons, neutrons, electrons, like for manganese and calcium 2 plus ions. Okay. So here this is manganese, this is calcium 2 plus ions, positive ions. Okay, so remember when we have an element like this, it is written to 55, for example. This is known as atomic number. You can see here, right? Atomic number exactly equal to proton numbers. So that means what is atomic number we have? This is yes, exactly. So we can say that this 55, this is 55 is given, right? Yes, 55 is given, that this 55 means this will be proton number plus neutron number, which is equals to nuclear number. Did you get it? Nuclear equals to number of protons plus number of neutrons. You can see here, right? And what is atomic number is given for this case? 25. That means atomic number is 25, number of protons is 25, number of electrons also 25. That's why for manganese I've written number of protons 25, number of the electrons 25 as well. As I told you, if proton is 25, for neutrons that equals to nucleon, which is given 55. If you rearrange it, 55 minus 25, that equals to 30. So we got 30 as well, right? When Ca2 plus ions, if you see this 20 is atomic number, 20 is the number of protons, right? And it is given 42. So 42 means what? Protons plus neutrons. So protons we have 20. So neutron, what should be? So it will be 42. If you subtract this, I'll get 22. So this answer should be 22. But be careful. Here 2 plus positive charge is given. That means 2 electrons is donated. That means it should have 20 if it is not donated. So donated 2 electrons. That means the answer is 18 for electrons. Did you get it? Okay. Manganese forms several oxides. The formula of some oxides is given: MnO, Mn2O3, Mn3O4, MnO2, Mn2O7, right? Suggest why manganese expected to form colored oxides. Okay, listen. For that, I told you already that from group 3 to group 12, right? If I try to show you that periodic table, you can see here group 3 to group 12, we can see here, right? These are known as transitional elements. These are known as what elements? Transitional elements. Okay, so in transitional elements you should remember the basic properties. What is the basic property we have? See, transitional elements can like form colored oxides, can have different oxidation number, acts as a catalyst, and high melting point and high densities or heavier they are, right? So you can see here why they form colored oxides, because manganese is present in transition element group. Do you understand? That means manganese is a transition element. That's why. State which other property of manganese is shown by formation of several oxides. Different oxidation number. I told you already that transition elements have different oxidation number. State the formula of manganese oxide, in bracket it's 2, right? What does it mean? So manganese will be 2 plus, and oxygen we know this 2 minus. If I try it write down, it will 2 will come here and 2 will come here, and if I simplifying, I'm getting MnO. Mn3O4 is found in an ore of manganese. Manganese metal can be extracted from Mn3O4 using aluminium as a reducing agent. Define the term. What do you mean by reducing agent? Very simple. Reducing agent is a substance that causes another substance to be reduced. Okay, and reducing agent is itself oxidized. That means what? It loses electrons. Got it? Complete the symbol equation by inserting the formula of missing product and balancing equation. Simple. You can see here that aluminium, right? So if this MnTO for aluminium, you can see here. So it will see, this is Al we have 3 plus like positive ions. Oxygen we have -2, that is oxidation number, we can say. So if I try to put 2 here, this is 3 here, it should be Al2O3, right? So I got Al2O3 here, and this is already given manganese. Do you understand clearly? Now how to balance this? Now you can see here, this is 9 manganese, right? 9. So to make it 9, this is all 3. So 3 times 3 is 9. So oxygen becomes 3 times 4 is 12. So this is, I'll put 4 here because 4 times 3 equals to 12 as well. But for aluminum, it will be 4 times 2 is 8. So I'll write down 8 here. This is how we can balance the equation. Got it, everyone? MnO2 reacts with a dilute hydrochloric acid as shown in equation. MnO2 plus 4HCl, that is MnCl2, 2H2Cl2. Okay. Calculate the volume of chlorine gas formed in centimeter cube at room temperature. RTP means room temperature. When exceeds MnO2 reacts with 50 centimeter cube of 0.200 mole decimeter cube HCl. Okay, DMQ. Okay, use the following steps. Calculate the number of moles of HCl used. Remember, this is a formula, that is concentration equals to mole over volume. I need to find the value of moles, rearrange it. So moles equals to concentration times volume. So concentration is given 0.2, right? This is 0.2 mole for DMQ, right? But if you see the question properly, this 50 centimeter cube is given. So I have to convert this into what? DMQ as well. So 1 centimeter cube equals to 1 over 1000 DMQ. Divide by 1000, you will get 0.05 DMQ. Got it? So 0.2 times 0.05, it becomes 0.01 mole. This is a formula, that is concentration equals to mole over volume. If you rearrange it, mole equals to concentration times volume. Did you get it? Next, determine the number of moles of Cl2 formed. Okay, that is okay. See, in this question, we have to use stoichiometry. What does it mean? Because there is no specific information is given for Cl2. So if you see the question, that 4 moles of HCl like produces 1 mole of chlorine. So I'll use that one. 4 moles of HCl will produce 1 mole of chlorine. That is a from given reaction I told you. So like that, here already I got 0.01 mole of HCl will produce how much of chlorine? So 0.01 over 4, that will be 0.0025 mole. Do you get it? Calculate the volume of Cl2 form. Listen, here already at room temperature, remember room temperature, what is the formula? That volume equal to mole times 24 dmq. Mole we have for chlorine, that is 0.0025. 24 will time for the 24 dmq for room temperature. So if you times it, I got 0.6 dmq, but I need the answer in centimeter cube. So when you convert dmq to centimeter cube times by 1000, you'll get the answer 60 centimeter cube. Describe a test for chlorine gas. Just remember, it should be damp blue litmus paper, and observation should be this should be bleached. Okay, explain in terms of collision theory why decreasing the temperature decreases the rate of this reaction. That means why, if you decrease the temperature, why the speed of reaction changes. See, these are the points you have to write down. What are the points? When you decrease the temperature, what happens? Definitely the kinetic energy of the particles reduces, decreased. So particles move very slowly and collides less frequently. So what happens? Fewer particles have activation energy. Therefore, fewer successful collision happens. Did you get it, everyone, clearly? Yes. Next, question number 6. This is from the organic chemistry. The structural formula of two compounds given, CS2 double bond CH3. If I try to write down, it will be 3 carbons and 6 hydrogens. CH3 CS double bond CH3. If you write down, it will be 4 carbons, 8 hydrogens, right? If you see this, C3H6 C4H8, this is coming in one family, that is called CnH2n family, or we can say alkene family, if you remember, right? Okay, let's start the question. A and B are the member of same homologous series, right? Give 2 reasons why the structural formula of A and B show they are the members of the same homologous series. Very simple, because they have the same functional group. They have the same functional group and they have the same general formula that I told you right now. Explain why A and B are both hydrocarbons. And what do you mean by hydrocarbons? The hydrocarbon means that will only consist or contain the hydrogen and carbo atom. That's why A and B, if you see, they have contain only carbon and hydrogen. That means it's known as hydrocarbons. Write the symbol equation for the complete combustion of A. I'm sorry. The A means which one? This one, right? C3H6. See, listen. Combustion means combustion means addition of oxygen. In presence of oxygen, it will start combustion. So complete combustion means it will produce carbon dioxide and water. Be careful. If the question would have given incomplete combustion, it would have produced carbon monoxide and water. Be careful. The question can be given like this. So C3H6 plus oxygen, that equals to carbon dioxide for complete combustion plus water. Next, you can balance yourself. For example, if you see this here, if I put 2 here, 2 so it carbon we have 6 and hydrogen we have 12, right? So carbon, to make it, I multiplied 6 here, so 6 times 2, oxygen becomes 12 as well. Sorry, oxygen becomes 12 here, right? So yes, here hydrogen is 2 to 6 times 2 is 12, and oxygen becomes 6, and here it is 12 plus 6 18. So that's why I put here 9 times O2 becomes 18. Got it? Deduce the empirical formula for A. Very simple. The empirical formula will be CH2. It's a family of CH2. Got it? Yes. Name the compound B. Compound B, where is that? This one. So you can write down as, because you can see here 4 carbon, that is alkene group. We can write down butene, or you can write down this way also, because but 4 and it is at the second place, it is double bond, that is 2, and it is alkene group, so I can write down but2ene. A structural isomer of B, a member of same homologous series. Draw and display the formula structural isomer of B. Very simple. You can see here what is the question is given, CH3 CH double bond CH3, right? So we have 4 carbons, 1 2 3 4. At second one we have to make a, what I can say, double bond, and each carbon will have 4 bonds. You can see here, be careful, one hydrogen, one hydrogen, one hydrogen, you can see here, and this is carbon carbon bond. Can you see this? So as we have this double bond, this is two bond, third bond, and this is fourth bond. So be careful. Again, for this carbon, two bonds, third bond, right? And this is fourth bond. So yes, this is the structural isomer of B. Now next part, compound B reacts with the aqueous bromine at room temperature to form a product C. So it is given CH3CH, CH3, bromine, and CH3CH-Br, CH-Br, CH3. Okay, state why it is an addition reaction. You can see here there is no other, what I can say, no other product. If there is only one product, so we can say this is an addition reaction. Describe the color change in aqueous bromine during this reaction. See, it can be orange to colorless. You can write down orange brown to colorless as well. Both answers will be exactly correct. No problem in that. Name the product C. You can see here, this is the product we have, right? You can see here how many carbon we have. 1, 2, 3, 4. So 4 carbon. So this is a like a group of butane. So alkane. So this is butane. You can see here at the second one and third one. So 2, 3 dibromo. Like bromine we have. So 2, 3 dibromo butane will be the name of this one. Under certain conditions, 1 mole of B reacts with oxygen to form 2 moles of carboxylic acids. Carboxylic acid D has 2 carbon atoms. Display. Carboxylic acid means you should know this is COOH, and this is how remaining like this, showing like this. C double bond, this is OH. Okay, this is known as carboxylic acids, and we have 2 carbons for this case. So 2 carbon, this is H like this. Okay. Name the carboxylic acid. This is known as ethanoic acid. This is known as what? The name of this will be ethanoic. CH3COOH. Complete the symbol reaction for this reaction. So CH3CH, CH3. So yes, when you add oxygen, so I'm getting carboxylic acids. So if you try to balance this, if I put, you can see here, here we have put 2. So yes, 2 oxygen, 2, this will be 4. So I put 2 and 2, that will be 4 as well. Okay, I think I've written somewhere else. Yes, yeah, describe the color change in aqueous bromine. This one, what if they would have asked you bromine reacted with the alkane, right? If it is alkane, then that will be saturated one, no reaction will happen. So it will be orange to orange. This is the answer could have been. Did you understand, everyone? So listen, this paper has been uploaded in my website called www.mathtonic.com. Okay, so please go there, click on study materials. You'll have the chemistry section. This solved paper I have given there. So yes, you can practice accordingly. So please do subscribe and share this video to your friends so you can have regular updates in your videos, and all the best for your exam. Thank you. Bye bye. Have a nice day, guys.